All right, guys. We're gonna be doing oh, am I sharing my screen? I think I am. All right, we're gonna be doing the Chatelier worksheet, principal worksheet. Let's get into it. For the direction below, which change would cause the equilibrium to shift to the right? So, number one's kind of weird because there's no because like C is the right answer because but there's no temperature in the problem at all. But you know, C is the right answer because A, B, D, and E don't make sense at all. They don't work at all. So like let's say for A, increases the concentration of dihydrogen sulfide. So dihydrogen sulfide's right here, right? So if you increase that, um, that will if you increase it, it will uh oh if you decrease it, right, then it will compensate by shifting to the left. Because we go to the side with less moles. So B, increase the pressure of the system, right? So pressure, you look at the moles of each thing. So on the reactant side, 2 plus 1 is 3. There's an invisible one right here. So there's 3 on the left on the reactant side, and then there's going to be 1 plus 4. It's going to be 5. So there's 5 on the product side and 3 on the reactant side. So if you increase the pressure, right, it will go to the side with less moles, which is the reactant side. So it will go reverse. So that doesn't work at all. D, was giving C, increase the concentration of carbon disulfide. Right, carbon disulfide is right here. So if you increase the concentration, it will go to the side with less moles, and that's well, reverse. Let's move to the left. So decrease the concentration of methane. Methane is CH4. If you decrease it, it'll compensate by going to that own side, which is reverse. So C is the only right answer because A, B, D, and E are all the same. All right, what would happen to the position of equilibrium when the following changes are made to the equilibrium system below? Oh, I want to have my thing ready so I can check my answers. Uh, where is my thing? I don't know. Okay, so for number two, sulfur dioxide is added to the system. Sulfur dioxide is right here, where my cursor is. If you add sulfur dioxide, it will go to the side. It will go to the other side, left. So it will be reversed. B, sulfur trioxide is removed from the system. Sulfur trioxide, this one on the reactant side. If you remove it, it will compensate by going to the same side. So that's to the left. That's still favoring the reactants, and that'll be reversed. So C, oxygen is added to the system. Oxygen is right here. Whenever you add something to one side, it will compensate by going to the other side. So same thing like A. Anything you add to the product side, it will shift to the left. So it will be reversed as well. So all three are reversed. So number three, A, HGO is added to the system. Now this is a little bit tricky because HGO is a solid. And as we know, solids do not count at all. So there will be no shift. And there's no shift because this equation is already at equilibrium. It's already equal. So not adding or not removing anything. There's just no change. So B, the pressure on the system increases. So the pressure is described by the moles, right? There's 2 moles right here. There's 1 mole of HGL liquid and 1 mole of O2. The pressure, it will go to the side, so we need to count out the moles, right? Um, Solids don't count, liquids don't count, so you only look at the gas. So there's only 1 mole of pressure for the product side, and for the reactant side, there's 0. So when pressure is increased, it will go to the side with less moles. So it will be reversed because the reactant side has none. All right, number 4. When the volume of the following mixture of gases is increased, what will be the effect on the equilibrium position? So when we're doing volume, it's the same thing as pressure. right? We count the number of moles. Or no, well, let's think about it, right? So Pivner, uh, I think for pressure and temperature, that's Boyle's law. So Boyle's law is, well, let me get rid of that annoying sound. Boyle's law is PV over T, or yeah, PV, PV. It's PV equals PV, right? And PV equals PV, they're inversely proportional. So if pressure goes up, volume has to go down. If pressure goes down, volume has to go up. So back to number four, right? Which if the talking about volume, Mr. Lee never talks about volume in the video lectures, but just know that just treat it like pressure, but the opposite, right? If that makes sense. So let's look count up the moles. So for the reactant side, there's 4 right here, and there's 1 right here. So 4 plus 1 is 5. So there's 5 on the reactant side. There's 2 for here, 2 right here, 4 on the product side. So 5 on the reactants, 4 on the products. If the volume is increased, let's just substitute it with pressure, right? If the pressure increases, it will go to the side with less moles. So that'd be product side, right? Because it's 4. But since it's volume, it's inversely proportional. So it would be to the product side. It would be to the reactant side. So that didn't make sense. Let me just break it down again. So for pressure, when you increase pressure, it would go to the side with less moles. However, for volume, if you increase the volume, it will go to the side with more moles of gas. So this will be reverse. Um, because when you increase the pressure, right? Theoretically, if you increase the pressure of a water bottle, right? There's more space, right? If there's a bigger amount of space, then the particles are going to be hitting the boundaries and the sides a lot more slower because there's so much room, right? It'll take slower for one to get to the other side, right? And so when you increase the volume, the pressure goes down. And so to compensate for Le Chatelier, it will go to the side with more moles of gas for more pressure. So more, so for volume, more volume. If you add more volume, it will go to the side with more moles. All right, so number 5. Predict the effect of decreasing the volume of the container for each equilibrium. All right, so number 2 for A, for decreasing the volume, right? So if we decrease the volume, it will go to the side with less moles of gas. So A, there's 2 plus 1, that's 3. 2 plus 2 is 4. So go to the side with less moles. So it'll be to the reactant side, reverse. B, 1, or actually, this solid doesn't count, right? So this would just be 4 on the reactant side. And so for the product side, it'll be 2 plus 1 is 3. So it's 3 on the product side, 4 on the reactant side. Side with less moles, product side. So forward. C, CO, 1 plus 1, that's going to be 2. 2 for the reactant side, 1 for the product side. So 1 on the product side, 2 on the reactant side with less moles, products, so forward. Number 6, predict the effect of decreasing the temperature on the position of the following equilibria. So for A, if we decrease the temperature, right? So in this case, if we decrease the pressure, if we decrease the temperature, it would go to the side, it would go to the same side because if we decrease the temperature, it will still have to compensate by going the same side for temperature that has a temperature sign in it. Because there's not enough temperature, right? You decrease it, there's not enough. So yeah, it has to go to the same side again. So that'll be forward. It's the same thing with pressure, right? Temperature and pressure, those are directly proportional, right? Temperature and pressure, that's Gay-Lussac's law. So Gay-Lussac's, that's gonna be V over T, right? So those are gonna be, that's gonna be P over T. So anything that has a pressure, well the same thing will apply for temperature. So basically for pressure, if you add more moles, if you increase the pressure, it will go to the side with less amount of moles. Um, Same thing with temperature. If you increase the temperature, it will go to the other side. If you decrease the temperature, it will stay the same side. So for B, um, since this is 37.2, but the enthalpy is required, so it's endothermic. So if it's required, then it's going to be on the reactant side. If you decrease the temperature on the reactant side, it will still go to the reactant side. So that will be reversed. For C, since this is exothermic, negative 27.6 is releasing it. It'll be on the product side. So you decrease something on the product side, that will be forward because it'll go to the same side. All right, hope that helps. Happy studying. Ba-ba-doo-ba-doo.